Students, this is question number 9. We've been given this curve y is equal to 3 negative 2x raised to the power of 3 positive 24x. We are asked to find dy over dx and d squared y over dx squared. This is for part A. Now there are two more parts. So foremost we will set off by solving part A. So let me start by stating here, given that y is equal to 3 negative 2x raised to the power of 3 positive 24x. What I would do is I can directly differentiate this, or I would just use chain rule. So consider 3 negative 2x raised to the power of 3 positive 24x is equal to y. Let u be equal to 3 negative 2x. So this means my y is u raised to the power of 3. Okay, so in fact I don't want to place this 24x there, because that would bring in an air of confusion. So let me just show you the differentiation of this term first. So as I mentioned to you, I'm going to be consider y is equal to 3 negative 2x raised to the power of 3, and then I'm going to take this assignment of u being equal to 3 negative 2x, which means y is equal to u raised to the power of 3. Now from here, if you were to differentiate with respect to x, we get, so what do we get here? You get du over dx is equal to, differentiation of 3 is 0, but differentiation of 2x would give me 2. So you have du over dx is equal to negative 2. So that's one part. Over here you differentiate with respect to u, and that would give us dy over du to be equal to 3 times u squared. So therefore the requirement dy over dx is dy over du multiplied with du over dx. What is my dy over du? 3 times u squared. What is my du over dx? That's negative 2. So this is going to be negative 6 times u squared dy over dx. But what is my u? U is 3 negative 2x. So therefore dy over dx is negative 6 times 3 negative 2x raised to the power of 2. So this is for the differentiation of this particular term. But we are given this term along with 24x. So therefore 24, or I would say therefore equation 2 can be rewritten as y being equal to 3 negative 2x raised to the power of 3 positive 24x. Differentiating with respect to x, we get. Now I have done all these things just to bring you the air of clarity. Okay, so this is going to be dy over dx is equal to, I've shown you the differentiation of this, which has produced us this result. So place that, negative 6 times 3 negative 2x raised to the power of 2. Positive differentiation of 24x is going to give me 24. So this is my dy over dx. But we need to get differentiation of this term one more time. So you can box this result to show the examiner. Now differentiating with respect to x again, we get, so what do we get? This is going to be d over dx of dy over dx, which is equal to d over dx of negative 6 times of 3 negative 2x raised to the power of 2 positive 24. Now this can be rewritten as, 6 is a constant, I am going to take that negative 6 out, d over dx of 3 negative 2x raised to the power of 2 positive d over dx of 24. Now this would produce a 0, but this is not of much keen interest to us. Now I'm going to show you how to differentiate this term. So let me consider yb equal to 3 negative 2x raised to the power of 2. So let me make this assignment. Let u be equal to 3 negative 2x. So therefore you got y is equal to u squared, and I'm going to be differentiating with respect to x. We get, so what do you get? Du over dx is equal to, differentiation of 3 is 0, differentiation of 2x is going to give me 2 with a negative sign. So therefore du over dx is negative 2. Over here you differentiate with respect to u. This is going to give me dy over du is equal to 2 times u. So therefore dy over dx is dy over du multiplied with du over dx. Dy over du is 2u, du over dx is negative 2. This is going to give me negative 4 times u. But what is my u? My u is 3 negative 2x. So 3 negative 2x, place that. So this is going to be my dy over dx. Now this explanation has been given to you just to show you how to differentiate this, but I'm going to take this as 3, right? So therefore 3 is now rewritten as d over dx of dy over dx, which is equal to, now differentiation of this term has been shown to you, which is producing me negative 4 times 3 negative 2x, positive differentiation of this term d over dx of 24 would give me 0. So place that 0. Negative negative positive, 6 times 4 is 24. So 3 negative 2x. And what is this? This is my d squared y over dx squared. Okay, so that is the solution for this question. What you can do is you can rewrite this. So hence you can state it like this. So dy over dx is what? This is the solution. Negative 6 times of 3 negative 2x, the whole squared, positive 24. And d squared y over dx squared is what? This is the solution, right? So 24 of 3 negative 2x. Now we are not done. This is only part A. Now part B is there. Now we need to go for part B. So part B states that we need to find the stationary points. Now stationary points is obtained. To get the stationary points, we set dy over dx to be equal to 0. So if I were to take this entire equation to be as 4, or the system to be as 4, so therefore 4 is going to be negative 6 times of 3 negative 2x the whole squared, positive 24 is equal to 0. So negative 6 times of 3 negative 2x the whole squared is equal to negative 24. You have two negatives, it becomes positive. We divide by 6, so this is 3 negative 2x the whole squared is 24 divided by 6 will give me 4. You take square root on both sides, and that would give me 3 negative 2x is equal to 2. So there are two values actually, 3 negative 2x, positive 2 and negative 2. So 3 negative 2x is equal to 2. You move this to the other side, bring this over here. So this is going to be 3 negative 2 is equal to 2x. So 1 is equal to 2x. So therefore 2x is equal to 1 and x is equal to 1 over 2. So you have a point there. And over here you move this negative 2x to the other side. You bring this negative 2 over here. So this is 3 positive 2 is equal to 2x. So 2x is equal to 5. So x is equal to 5 over 2. Now we need to get the nature, right? So that is also a very important part for the question to be solved. Before heading on to part C, we will have to find the stationary points. So the stationary points are, now when x is equal to 1 over 2, we have to substitute it in the original curve. Okay, y is equal to 3 negative 2x raised to the power of 3 positive 24x. So we need to put this. So this would become y is equal to 3 negative 2 of 1 over 2 raised to the power of 3 positive 24 of 1 over 2. So 2 gets cancelled, giving me 1. So 3 negative 1 over raised to the power of 3 positive 2 divides here 12 times. So this is going to be 3 negative 1, that's 2 raised to the power of 3 positive 12. So 8 added with 12 is going to be 20. So therefore when x is equal to 1 over 2, you have the point 20. Now when x is equal to 5 over 2, right, that's what you've got, 5 over 2. So substitute that. So y is equal to 3 negative 2 times 5 over 2 raised to the power of 3 positive 24 times 5 over 2. So 2 gets cancelled. This is going to be 3 negative 5 raised to the power of 3 positive 2 divides here 12 times. So 12 into 5 would give me 60. 3 negative 5 is 2 raised to the power of 3 positive 60. This is negative 8 positive 60, which is 52, right? So therefore when x is 5 over 2, you get 52. So hence, sum it up. The stationary points are when x is equal to 1 over 2, you get 20, and x is equal to 5 over 2, you get 52, right? So this is a curl bracket. So we box this result, and now we need to find the nature. Now to get the nature of the stationary point, we consider the double differential d squared y over dx squared, which is 24 times of 3 negative 2x. Okay, now at x is equal to 1 over 2, you need to substitute that value. You need to find what is d squared y over dx squared. So this is 24 of 3 negative 2 of 1 over 2. 2 cancels, giving me 24 of 3 negative 1. This is 24 of 2, which is 48, and this 48 is actually greater than 0. So this means 1 over 2 comma 20 as, or you can say as a local minimum, or you, instead of saying as, you can simply state is a local minimum. You don't have to use as, you can just say 1 comma, or I would say 1 over 2 comma 20 is a local minimum. So that's a better way maybe. Now at x is equal to 5 over 2, substitute, find d squared y over dx squared. So what is that? 24 times 3 negative 2 of 5 over 2, right? 2 gets cancelled, giving me 24 of 3 negative 5, which is 24 of 3 negative, in fact I can simply state the value. So this is negative 2, which is going to be negative 48, which is less than 0. So this means 5 over 2 comma 52 is a local maximum, or produces a local maximum, right? So that is the conclusion for this question. We move on to the next one.